Today we're going to put the previous videos together and work on some more worded questions using trigonometry and Pythagoras. So before we start, we need to go over angles of elevation and angles of depression. So basically this tells you where the angle will be located that we'll be working off in each triangle. We'll start with angles of elevation. So angles of elevation are measured up from the horizontal to the line of vision. So in this example triangle on the left here, we have our horizontal being, let's say, the floor. We could say that this is the height of a tree, and this is the line of vision the person is looking at to the top of the tree, or any other worded example. If they had given us the angle of elevation to say be 30 degrees, to put that in this triangle, we need to go from the horizontal to the line of vision. So in this case, our 30 degrees or our theta, our unknown angle, would be this angle here, from the horizontal up to the line of vision. That's angles of elevation, and normally they're the easier ones to find in diagrams because most of the time the questions are about someone looking up to something. Whereas angles of depression are measured down from the horizontal to the line of vision. So let's say we've got the same triangle as before, and they told you that the angle of depression was 30 degrees. Now, what you could see here is we've got a horizontal, but the only line of vision or line coming off the horizontal would be up from the horizontal. Angles of depression always work down from the horizontal. So in some cases, you actually need to draw an alternative horizontal in, let's say at the top of the triangle, like so. Now we can have an angle of depression. Now this angle of depression would be this angle here, from the horizontal down. And that we could call that the theta. What we have to be careful of is that's not in the actual triangle itself. So normally you would then need to work out, well, this whole angle here is a right angle, so this angle x is going to be 90 subtract theta. And that's normally what occurs in the worded question. It's unlikely that the angle of depression is actually going to be an interior angle to your triangle. It normally will be one like this, where it will be an exterior angle, and you'll need to use complementary angles to determine the interior angle here. So they're normally the more challenging questions. The other thing we need to look at is compass bearings and true bearings. Okay, so we've got two types of bearings. There are compass bearings and there are true bearings. Now, it's more likely that you'll come across true bearings in your questions, but we will go over compass bearings just in case. So, first of all, with compass bearings, we always start with a letter, and now this first letter is always going to be north or south. We then put the appropriate angle in, and then we have the last letter, which can be east or west. But we always start with north and south, and basically how many degrees do we move to the east, or how many degrees do we move to the west. For example, let's say I put this line in here, and that I know that this internal angle here is 50 degrees. I would call this bearing north, because we started at north and we went 50 degrees to the east. Likewise, another example. Let's say we have this example here where we can see that the angle is the angle of depression from the west down. Even though that angle is going from the west, we always in compass bearings work from north or south. So I know that this is a right angle. If we've gone 15 degrees from the west down, then this angle here must be 75 degrees to make that a right angle. So this compass bearing here must be south 75 degrees west. So this number in the middle here can never be more than 90, and we always start with south or north and then we work to the west. The more likely situation is that you'll be asked to find a true bearing. Now, true bearings also have a very set way of notating. Now, we always use 3 digits, so even if our angle's only 1 degree, we write 0, 0, 1. Then we have degrees and T standing for true. The other thing about true bearings is that we always work clockwise around our compass. So if we had the exact same bearing from the first example, we would call this 0, 5, 0 degrees true. Likewise with the second example, this example here, we've got 15 degrees from that west line, which is 270 degrees. So in this case, that angle is going to be 255 degrees true. So no matter which bearings example you're given, it's really important that you stick to the set notation for each of the types. So now we'll try a few examples. So all of these examples are going to be worded type questions. With any worded question, it's really important you highlight the key information. So the Cape Byron Lighthouse is situated on a cliff at the most easterly point of the Australian mainland. From a point on the ground 50 metres from the base of a lighthouse, the angle of elevation to the top of the lighthouse is 20 degrees. Calculate the height of the lighthouse to the nearest metre. Now with these questions, again, pens is really important. Picture, equation, numbers, solution. So the first thing we need to do is draw a picture. Now, in an assessment situation, your pictures don't have to be perfect, but they should try as best as you can be drawn to scale. So the first thing I would do is draw my lighthouse, and you might just draw a big thing like this with a light on the top. It doesn't have to be perfect. Don't be drawing the black and white squares around it, just a simple lighthouse. The next point was that it's from 50 metres from the base, the angle of elevation. So the next thing we need to draw is our base and the 50 metres away. So something like this, 50 metres away. The angle of elevation to the top of the lighthouse is 20 degrees. Now remember, the angle of elevation is from the horizontal up. So if I draw my line of vision in here, the angle of elevation is going to be 20 degrees. We're going to assume that the lighthouse is vertical, so that will be our right angle here. The last bit is our unknown is the height of the lighthouse, which would be x. So I've drawn my picture. Now I need to solve for x. So from this angle, that's my opposite side. I've got my hypotenuse being across from the right angle, and this side must be my adjacent. I recognise that I have the opposite side and the adjacent side involved in this question. So that's going to be the tan ratio. So I put my equation in. Tan of theta is the opposite over the adjacent. I then, with my numbers, substitute in what I know, which is tan of 20 degrees is going to be the opposite, which is x, over our 50. We're then going to rearrange the equation to make x the subject. So x is going to be equal to 50 multiplied by tan of 20, which gives us an answer which is equal to 18.199 to the nearest metre, that is 18 metres. So most important with worded questions, highlight the key information and draw a suitable diagram. We'll try a few more. So let's try this question now. So again, we're going to highlight the key information. A ship at sea has travelled 1,000 kilometres on a bearing of north 40 degrees east since it's left its port. Calculate draw a label diagram to display the distance travelled east and the distance travelled north. Then use trigonometry to calculate these distances. Okay, so we're going to start with drawing the port. Now recognising that we've gone northeast. So when we start our port, we don't want to start the port too high, so we don't have anywhere to go, and we don't want to start it too far to the right. So bottom left is always a good place to start for these sorts of questions. So we'll start with a port being here and we'll label it. And when we're doing bearings, you always should draw your north in. So we're thinking there's north, 40 degrees will be about here, and we're traveling out for 1,000 kilometers. So we've got our boat at the dock and there's 1,000 kilometers. Now the question wants to know how far east and how far north, and we're going to put these on the diagram. So how far east is going to be, well, how far horizontally have they traveled? So there's our how far east. And then our north, same thing, but we're going to go how far north have they traveled all up. And that's going to be our n. Now we can use trigonometry to calculate these distances. So hopefully what you can see here is we have two right-angled triangles. So if we work with the east first, so if I finish this triangle and there's my right angle, we want to know how far east they've gone. The other thing I forgot to add to the diagram is that this is 40 degrees. So working out the east first, we'll call this BI to make it easier. I don't actually have an internal angle on my triangle yet, so I checked to see if I can use Pythagoras. To use Pythagoras, I have to know two sides of the triangle. I only know one, so I'm going to have to use trig. So then I go to try and work out and see if I do have an internal angle. What I know is that this whole angle has to be 90. I've got 40 degrees here, so what must be left here is the 50 degrees. And in a lot of worded questions, you're going to have to use your complementary and supplementary angles knowledge to work out unknown angles. Now that I know that this is 50 degrees, I have something to work with. I have the hypotenuse, and this side is my adjacent side to the 50 degrees, so I'm going to use cosine. Again, I write my equation. Cosine of theta is the adjacent over the hypotenuse. I then fill in what I know. So the cosine of 50 is going to be equal to, we'll call it E over our 1,000. Rearranging the equation, E is going to be equal to 1,000 multiplied by the cosine of 50, which gives me an answer of 642.788. They want it to the nearest kilometre, so this is going to be 643 kilometres, and that would be east. We're now going to do the same thing for north. Now north will have a different triangle to work with. We would close the triangle in here. Now we could potentially use the value we've got for east, but remember we're always best to use the values given to us in the question. So at the moment we have the internal angle. We know the right angle would be sitting here, so therefore we have the hypotenuse, and we're looking to work out north, so we have enough to work with doing trigonometry. Again, we go through and see our sides. I know I have the hypotenuse, and I know I have the adjacent side again as my north side. So to do part 2, we're going to be cosine of 40 degrees is going to equal my north over 1,000, which, rearranging the equation, north is going to be 1,000 multiplied by the cosine of 40, which gives us an answer of 766.044. To the nearest kilometre is going to be 766 kilometres, and that's going to be north. One more question. Sendona is standing, again highlighting our information, 20 metres in front of a wall. From her eye level, 168 centimetres above the ground, the angle of elevation to the top of the wall is 25 degrees. Part A, draw a diagram. Part B, find the height of the wall. So again, drawing our diagram doesn't have to be perfect. We've got Sendona standing here, we'll call her S. She's standing 20 meters in front of a wall. And again, we know that floors and walls in maths meet perfectly with at a right angle. From her eye level, the angle of elevation to the top of the wall is 25 degrees. I'm just going to replace this S with her height, which is 168 centimeters, and we'll put the S here. Now, the angle of elevation to the top of the wall is 25 degrees. We know angles of elevation have to go from the horizontal up. At the moment, we don't have that. We actually don't have a triangle. So we're going to add in a horizontal here at her eye level. Now I can put the angle of elevation up to 25 degrees here. And they want us to find the height of the wall. So the height of the wall, we can find this X here. We already know her height is 168 centimeters, which would go here. If we add X to 168, that will give us a total height. We also know that this is a right angle here, and this must also be 20 meters. So we use trigonometry to find this X. There's our hypotenuse, our opposite and adjacent. We can see that we're going to be using the opposite and the adjacent, which makes it the tan ratio. So tan of theta is the opposite over the adjacent. Substituting our values in, tan of 25 degrees is going to be X over 20. Rearranging the formula, X is equal to 20 multiplied by tan of 25 degrees, which gives us an answer of 9.326. Now, they haven't actually asked for any specific rounding. Now, because they've given us 168 in meters, that would be correct to 2 decimal places. So it's always good practice to go one more than what they've given you, one more decimal place. So let's add these together. We know that this answers in meters because we've used the 20 meters. So total height is going to equal our 9.326 adding our 1.68, converting this 168 centimeters to 1.68 meters, which is going to give us an answer of 11.006, which in this case would be 11.01 meters, and that would be accurate enough for this question.